Educator.com. In today's lesson, we're going to be discussing how to factor the difference of two squares. So first recall that the difference of two squares, so a term such as a squared minus b squared, equals a plus b times a minus b. So we have two squares and the difference between those. So knowing that this pattern exists, we can use that to quickly factor when we see something in the form a squared minus b squared. For example, x squared minus 16. This is the difference of two squares. So I know that x squared equals a squared and b squared is 16. So I take the square root of each side and that tells me that a equals x and b equals 4. So this can be factored out as x squared equals a plus b. So a is x and b is 4 times a minus b, where a again is x and b is 4. So again, by recognizing this pattern, you can much more quickly factor these type of expressions. And just to show yourself that this indeed is true, you can always use FOIL to check your answer. So if I multiply out my first terms, that would give me x squared. My outer terms would be minus 4x, inner plus 4x, and then the last terms minus 16. You see that these middle two terms cancel out because I have a minus 4x and plus 4x, and this gives me x squared minus 16. So I can always check my work that way. Sometimes you have to use more than one technique in order to factor an expression or an equation. No matter what though, always begin by factoring out the greatest common factor. The reason for that is if you take out the greatest common factor, you'll be working with smaller numbers. So it's much easier that way. So the first step, no matter which technique or techniques you're going to use for factoring, is to remove or factor out the greatest common factor. So we've learned several methods so far. We've talked about factoring by grouping, using trial and error with lists of possible factors and then figuring out which one fits the situation. We've talked about factoring when the leading coefficient is 1 or when it is not 1, and now talking about the difference of two squares. So there's multiple methods that you can use, but let's look at one example. 16x to the 4th minus 36x squared. So if I look at this, as far as the numbers go, I see that I have a common factor of 4. So let me figure out my greatest common factor. First, looking at the numbers, both of these have factors of 4. And then I look at my variable terms, and I look at the variable with the smallest coefficient. So this has x squared, therefore x to the 4th contains that. So my greatest common factor is actually 4x squared. I go ahead and pull that out and see what I've left behind. Well, if I take the 4 out, 4 times 4 is 16, so I have a 4 left behind. If I take an x squared from x to the 4th, I have an x squared left behind. Doing that for the second term, pulling 4 out of 36 by factoring leaves me 9. And if I factor out the x squared, I have no variable term left behind. And as always, you can check your work by multiplying out to make sure you get back the original expression. Now that I've done that, I look and see what I have, and I have the difference of two squares inside the parentheses. And dealing with the smaller numbers in this expression and less variables makes it easier to recognize that and to factor. So if I were to finish this out, I would Remember that a squared minus b squared factors to a plus b times a minus b, or 2x plus 3 times 2x minus 3. I could have certainly just factored from here and then taken out the GCF after, but it would have been more work that way. And I always like to do the least amount of work possible. In order to solve equations, the first step is going to be moving all terms to the left side of the equation. Then you'll factor that left side and finally use the zero property. So there are 3 steps to solving equations, and we say try to solve equations because there are some equations for which there are no solutions. And you'll see one of those occasionally. Okay, so let's look at an example. X squared minus 4x equals 32. Okay, so I'm going to subtract a 32 from both sides because my first step is to move all terms to the left side. That gives me x squared minus 4x minus 32 equals 0. Second step, factor the left side. And remember that we've talked about factoring trinomials when you have a coefficient, a leading coefficient of 1. So if you were to use those strategies, you'd come up with x minus 8, x plus 4 equals 0. Okay, so first I moved everything to the left side. Then I went ahead and I factored. And finally, I'm going to use the zero property. Remember that the zero property tells us that if a times b equals 0, then either a equals 0, b equals 0, or they both equal 0. Knowing that, I can break this out into x minus 8 equals 0 and x plus 4 equals 0. Solving that out by adding an 8 to both sides gives me x equals 8 and x equals negative 4. So my solution set for x is negative 4 and 8. Again, move all terms to the left, factor that left side, and use the zero property. Okay, in the first example, I look up here and I notice that I have an expression in the form a squared minus b squared. So this is the difference of 2 squares. And I recall that this factors to a plus b times a minus b. So I'm looking and I have 16x squared equals a squared. And I have 49 equals b squared. If I take the square root of both sides, I can get a squared. I can get a. So that would be 4x equals a. For b squared, take the square root of both sides, I have b equals 7. So once I've found a and b, it's just a matter of using this format that I already know. Okay. And therefore 16x squared minus 49 equals a plus b, so that's 4x plus 7 times a minus b, or 4x minus 7. Again, I recognize that I have the difference of 2 squares and that it's going to factor out into this form. I found a and b, and then I put my factored expression into that form. Okay, in this second example, I see that I'm working with some pretty big numbers, and so I definitely want to look for a greatest common factor because that's going to make this much easier to work with. So 64x to the 4th minus 100x squared. In terms of the numbers, I do have a greatest common factor of 4. If I look at the variables, my x term, my variable here with the smallest coefficient is x squared. So I can pull an x squared out from both of these. So 4x squared is the greatest common factor. So I go ahead and factor that out. So first step is factor out the GCF, if there is one. So when I pull out this 4x squared, what's going to be left behind in the parentheses is 16x squared minus 25. And I can always check that by saying 4x squared times 16x squared, 4 times 16 is 64. X squared times x squared is x to the 4th. Same thing with this term. 4x squared times 25, 4 times 25 is 100, x squared. Okay, so now that I've done that, I can recognize that I do have the difference of two squares for this term in the parentheses. Recalling that a squared minus b squared equals a plus b times a minus b. I'm going to go ahead and factor this out. Now, the one thing to remember is you've got to bring this greatest common factor along, because sometimes you'll get going with the factoring, you're paying attention to what's going on in the parentheses, especially if it's complicated, and you forget to bring along the greatest common factor. So I'm going to write that first so that I don't forget to bring it down. Then I'm going to go ahead and factor this out. And I need to find a, so the square root of 16 is 4. The square root of x squared is x. So a plus b, square root of 25 is 5. And then a minus b. This was much easier to work with since I pulled out the greatest common factor. And then after that, I made sure I brought that down, and then I just went ahead and factored this out into 4x plus 5, 4x minus 5. Okay, in my next example, I have a polynomial with 4 terms. And again, when I see large numbers, I see there's a variable, the same variable in each term, I'm really thinking about greatest common factor, which would make this much easier to work with. So it might not be obvious what the greatest common factor is. It's actually 6, but even if you didn't recognize that right away, you might have thought that it was 2. You could pull out the 2, and then you might have seen that you had a 3 left behind still as a common factor of all the numbers. If you saw that, then you could just say, okay, it's 2 times 3, which is 6. So the greatest common factor is actually 6. So if you pull out one that's too small and you see you have another common factor left behind, you just go ahead and pull that one out. Okay, so for my greatest common factor, for the numbers, 6 is the greatest common factor. For the variable, the smallest exponent I have for any of the x's is 1. So there's really a 1 there, but we don't write it out. So x. Pulling out that greatest common factor, writing it outside the parentheses, it's going to leave behind 4x cubed. 6 times 4 is 24. And then x times x cubed is x to the 4th, minus 20. And then I pulled out an x, so I have an x squared left behind. 54, I've pulled out a 6, that's going to leave me with 9. And I've pulled an x out, so 9x. And then actually 45 times 6 is 270. So there I have a 45 left, and then I've already taken out my x. So this is what's left behind. Now, I would handle this by using grouping, because I've got a polynomial with 4 terms. So I'm going to use grouping. Recall that to use grouping, you're going to group the first 2 terms and the second 2 terms. And I'm careful to bring that greatest common factor along as I work with this. Okay, with grouping, after you've grouped the first 2 terms and the second 2 terms, the next step is going to be out to pull a common factor from each set of 2 terms. For this first set, 4 and 20 have a common factor of 4. The x terms, x squared is the smallest exponent here, so it's going to be 4x squared. Okay. So pulling that out is going to give me x minus 5. So I'm left with x minus 5. This second set of terms over here, that should be 45, has a common factor of 9. So I pull the 9 out, and that's going to give me negative x plus 5. Okay, I look at this, and now I want to factor out the common binomial factor. I don't quite have one, but I can modify this, do something else to it so that I do have a common factor. X minus 5 and negative x plus 5. Those differ just by the signs. That means if I factor out a negative 1 from one of these, they'll be the same. Okay. So I'm going to factor a negative 1 from this second expression over here. Now I've got a common binomial factor, and when I see that, I can factor that out. So I'm grouping the 4x squared minus 9, and then I'm just factoring out x minus 5. So I end up with, again, bringing that greatest common factor along the whole time, 6x times 4x squared minus 9 times x minus 5. Now, one thing you may notice is that 4x squared minus 9 is the difference of 2 squares. Difference of 2 squares. So this is going to factor out to this form, a plus b, a minus b. So a will be 2x, b is going to be 3. So 2x plus 3, so in this form, 2x minus 3, and then I still have my x minus 5. So this was a bit complicated, but made easier by pulling out the greatest common factor, and then looking and saying, okay, I can use grouping because I have a polynomial with 4 terms. Then grouping the first 2 terms, second 2 terms, pulling out my common factor from each, factoring out the common binomial, and then recognizing that I ended up with the difference of 2 squares, which I could easily factor into this. So this is the factored form of this expression that we were given. Okay, in number 4, I have an equation. The first step is put all the terms on the left. Therefore, I'm going to subtract 48x squared from both sides. Now, once I've done that, I've got something I can work with. Second, I'm always going to look for a greatest common factor. And if I have one, I'm going to factor out the greatest common factor. So looking at this, I do have a greatest common factor. This is 48. So 3 times 16 is actually 48. Therefore, you have a common factor of 3. Looking at the variables, I have a common factor of x squared. So I'm going to go ahead and factor that out, and that's going to give me 3x squared. What's left behind here is x to the 4th. What's left behind here is 16. equals 0. Okay, so I put all the terms on the left. I pulled out the greatest common factor, and then I'm going to factor the remaining expression. By remaining expression, I'm talking about everything that was left behind that was not pulled out as part of the greatest common factor. Well, I look at this and I have the difference of two squares. The difference of two squares, x4 minus 16. So when I have the difference of two squares, it's going to be factor into this form. Bringing along my greatest common factor, 3x squared. The square root of x to the fourth is x squared. Square root of 16 is 4. Okay, so let's look at what we have. We have 3x squared times x squared plus 4 times x squared minus 4. We can go a little bit farther with this because this is also the difference of two squares. So I just repeat this process, 3x squared, and then x squared minus 4 factors out to x plus 2, x minus 2. Now I've got it factored out as far as I can, and it's time to actually solve for x. So I'm going to use the zero property. To solve for the variable. And I have 4 terms, but that's fine. The zero property applies to more than 2 terms. So you could have a times b times c times d equals 0, and then either a or b or c or d equals 0. So let's write these all out. 3x squared equals 0. X squared plus 4 equals 0. X plus 2 equals 0, and x minus 2 equals 0. So I'm going to solve these, and these are going to give me my solutions for x. So just taking them one at a time. The first one is that 3x squared equals 0. So that means that x squared equals 0, because if I divide both sides by 3, that's what I'm going to get. Take the square root of both sides, x equals 0. So that's my first solution. So my solution set for x is going to contain 0. Now here, I'm going to subtract 4 from both sides to get x squared equals negative 4. Now, what I need to do is take the square root of x squared and negative 4. The problem is I can't do that. For this course, this would give us no solution. And the reason is that the square root of a negative number is not a real number. And we're limiting ourselves to working with real numbers in this course. So for this, I can't do that. So there is no solution. That is not going to be this value is not going to be part of my solution set because it involves complex numbers, not real numbers. Okay, for this next one, x equals negative 2. Okay, so that's part of my solution set. And then finally, x equals 2. So I have 3 solutions for x, 0, negative 2, and 2. And I got to that by putting all the terms in the equation on the left, factoring out this greatest common factor, factoring out the rest of the equation, and then using the zero property to solve for x. That concludes this session of Educator.com, and I'll see you soon.